Hello and welcome to this short video explaining how we would find the acceleration of in this case, a helicopter. And these kind of questions, they fundamentally rely on an understanding of Newton's laws. So we'll first refresh our memory of Newton's first and second law. And here's Newton's first law. Every body continues in its state of rest or of uniform motion in a straight line, unless it is compelled to change that state by forces impressed upon it. And Newton's second law, the change of motion of an object is proportional to the force impressed, and is made in the direction of the straight line in which the force is impressed. But usually you will refer to this as F equals ma. But to really understand these equations, we can picture a few different physical situations that we all know. So the first one is whenever we're on a train and it's just starting to move, you can feel the acceleration in that case. Now when the train has sped up and it's coasting at a more or less constant velocity, there'll be periods of time where you're sitting on the train where you don't feel, if you were to close your eyes, you wouldn't really feel like you were moving. And that's the difference between these two cases. So in the first case where the train's accelerating, we can feel the force. In the case where it's continuing in uniform motion rather than accelerating motion, you can't really tell. If you had your eyes closed, you wouldn't be able to tell that you were accelerating. An even more dramatic example is when an airplane takes off. When it's accelerating along the runway, you literally are pushed into your seat, and you would find it difficult to stand up, and they make everybody sit down because people will be falling over and everything. But then once the airplane's up and coasting, then everyone's allowed to walk around again when it's moving at a constant velocity. How this relates to our question is that this is a case where we're told that it's accelerating. So in order for it to be accelerating, then there must be a force impressed upon it, as it says here. Another situation we can picture is in a tug of war. So there's two teams of people pulling on a rope, and there's maybe something hanging in the middle of the rope to mark that point is going to move. If the team on the left, for example, pulls harder, they'll win. So everyone's trying to generate as much force as possible, and it's only whenever there's an imbalance of forces that the rope will accelerate to the left or to the right. So what we need to do is we need to find the resultant force of the downward weight of the helicopter and the upward lift from the helicopter blades. And once we find the resultant force, we can then use this equation F equals ma, with the F as the resultant force, to tell us the acceleration. So here's a simple example explaining the idea of resultant force. If there were two teams playing tug of war, and one team pulled to the left with 1000 newtons and the other to the right with 900 newtons, then the resultant force would simply be 1000 take away 900 equals 100 newtons to the left, and the rope would move to the left. So in the case of this helicopter, we'll just have to find the resultant force. And we'll do that by first finding the weight of the helicopter. Remember, the weight is not the mass, the weight is the force. The weight is the force experienced by the helicopter due to gravity. So were this same helicopter, for example, on the moon with the same mass of 2100 kilograms, nevertheless it would actually experience less force due to gravity, because the moon's gravity is so much weaker, and it would have a much lower weight. So let us find the weight of this helicopter. And to find this weight, we just use F equals ma, with m equal to 2100, because that was the mass of the helicopter, and a equal to little g, the acceleration due to gravity, which equals 10. So then we would have a weight of 2100 newtons. So then we'll move on to the second part of this process, which is to calculate the resultant force. So remember, that is going to be this downward force of the weight taken away from the upward force of the helicopter blades, and that upward force was given as 26,000 newtons. Okay, and that works out to be 5,000 newtons. So now we need to take this resultant force and use the equation F equals ma again to find acceleration. But before we do that, we'll rearrange the equation to make A the subject. So we can see here that if we simply divide both sides of the equation by m, we will have A equals F over m. And I will substitute in these values. Okay, and here we can see that when we put in the 5,000 for the force, which was the resultant force we found, divided by the mass of the helicopter, which is 2,100 kilograms, we find an acceleration of 2.38 meters per second squared.